Hello, my name is Fabo Feng, and I'm a postdoctoral researcher here at the Carnegie Planet and Earth division. Basically, I just developed different algorithms and softwares to find planets efficiently and reliably, especially want to find Earth-like planets. Yeah, I'm an explorer. Especially, I want to find Earth twins, which are Earth-like planets orbiting around Sun-like stars. I think I've discovered more than 40 exoplanets. Yeah. I've used the so-called radial velocity method, which is also called orbital method. This method is based on the fact that a star will be perturbed by its planet, and when the star moves towards us, the light from the star will be blue shifted. When it moves away from us, the light will be red shifted. So from this periodic blue and red shift light, then we can detect exoplanet. And the other very frequently used method is so-called the transit method, that when a planet moves in front of a star, it will block the light from the star. It causes a dip in the light curve of the star. And then from these periodic dips in the light curve, we can find out whether there is a planet. So these are the major two methods used in this field. I think for many people, exoplanets are important because they can help us to understand the formation and the evolution of planets. And for others, probably they want to know more about the exoplanet themselves, especially the atmosphere and composition of the exoplanets. And for me, I think most important reason I study exoplanet is to find out whether the Earth is unique and the solar system is unique, whether there are extraterrestrial life and even intelligent beings over there in our galaxy. Yeah, that's my motivation. We've just recently published a paper reporting 16 exoplanets. Especially there are 3 exoplanets which are very interesting. Especially there are 2 exoplanets in so-called habitable zone of their host stars. For example, one planet called GJ180d, it is located in habitable zone of an M star, which is less massive than the Sun. When we say habitable zone means the region around the star where liquid water can exist on the surface of a planet. And this is the minimum requirement for the existence of life. The unique thing for this planet is that this planet is not tidally locked to the star, because previously many habitable zone planets are discovered to be tidally locked to the star. Only one side of the planet faces to the star. So just like the Moon and Earth system, only one side of the Moon faces at the Earth. So that will make one side of the planet very hot and the other side is very cold, so it's not good for habitability. So this unique planet is the first one which is more likely to be habitable. During the last 4 years, I've developed many algorithms to make the discovery of exoplanets efficiently, especially using the radial velocity method. And there are many signals in radial velocity data. For example, the stellar activity can also introduce radial velocity variation, and also the planets, as well as the instrumental bias. So in order to remove all this noise, to model them correctly, I've developed a software called Agasa to do this correctly. I've also recently developed a Pexel package, which is used to precisely model the radial velocity data to even centimeter per second precision. So with these 2 packages, I think my approach is more reliable and more efficient because it is highly automated. So that's the reason why I can discover more than 20 exoplanets during my last year here in Carnegie. all the Agasa and the Paxo packages and source code can be found on GitHub, and it's open sourced and it's well documented, so people can use it for different purposes. This is a rule in this community, and also I would like different people, even different groups, to check my results and also test the conclusion. So I want to make my softwares open sourced, and so people they may use it or apply it for other data sets or different problems. Yeah, this is a healthy habit for the community, I think. Probably the Proxima Centauri or Alpha Centauri. Proxima Centauri is very hostile to life because there are many activity of the star that will destroy probably the atmosphere of the planet. But for Alpha Centauri A and B, which is our nearest sun-like star neighbors, I think they're more likely to host life. If there's a habitable zone planet, probably, yeah, we have chance to travel there. Favorite planet probably is the Earth. My favorite exoplanet is Proxima b. Oh yeah. So for different people, they have different answers, but I think it's very difficult to answer this question because as for people who are scientists in 19th century, they may not predict the discovery of quantum physics or general relativity because these ideas are genius and we cannot predict. But from an optimistic point of view, that I think we will probably discover most of exoplanets in the galaxy, down to the size of Mercury, and we may find life in other exoplanets. Yeah, we may even find extraterrestrial intelligent beings because currently we use radio telescopes to detect techno signatures from them. And if intelligent beings are coming in our galaxy, we probably will find them in this century. So, but that is very optimistic. Personally, I believe that the study of science is very rewarding, although it is very hard for some people. So I think it's not just about doing some work, but also about changing yourself, changing your worldview, and also change your knowledge of the outside world and the knowledge of yourself. So gradually, as a scientist, I think we should be more and more humble and more open-minded so that we can make more discoveries and reach out to the public, so let them to have a scientific worldview. Yeah. I find that Carnegie Planet division is quite unique, that many people, they study different subjects. I believe that exoplanetary science is interdisciplinary research that we need different kinds of people with different expertise to collaborate. Yeah. So that's the main reason I come here. Thank you. Good to have an interview.